our next question. And here we're going to get into some very complex stuff. This question is titled, How do I match contextually? And we're going to talk about back references, look ahead, and look behind. And now we're going to start getting a little bit beyond the regular expressions that you might have written when you do a grep and an egrep. Let me show you where this might come up. Let's say we have some file and it has some data, and some of these data items are commented out. How do we make sure that we only match the ones that are not commented out? And so here you can see if I do a find iter for each sequence of digits, it'll find the 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I didn't quite do what I wanted to do. So let me actually do a little bit of string splitting, because at least I know, I can split this, and one line contains all the data I want. This is line-orientated data. And I'll do a full match. And if I look for only digits, okay, that seemed to work. Great. So here, I could just say, okay, match anything that is just a digit with a full match, and I'm good to go. And what I could do is I could choose whether or not the spaces matter. So I could choose whether I want it to start at the beginning of the line or whether I'm going to allow there to be spaces beforehand. And so it'll match these. And so this is actually pretty straightforward for me to do. I didn't need anything too fancy. I could also handle a situation where maybe some of these are skipped because there's a comment at the end of the line. So here, I could say, okay, I'm going to grab anything except that 4, 5, 6, anything that happens to have that skip there. So what I'll do is I'll do another one of these split it on lines to do a full match and match anything where the entirety of the line happens to just be numerical data. Okay, that's pretty good. Or what I could do is I could do my find iter, and I could match such that the end of the line happens to be the digits. So here, if there's any white space, it won't match. But here, there's some extra junk at the end of the line, so it won't match. But remember, when I'm matching this multi-line string, I need to use this multi-line flag. So to make this $sign mean the end of the line, not the end of the string as a whole. And so that largely worked. Now, I want to talk about negative look ahead, because there's another way I could solve this problem. Another way I could solve this problem is I could make an assertion. For the most part, when you think of each of the mechanics of a regular expression, you're thinking about these in terms of parts of the state machine, nodes that consume characters. Negative and positive look ahead and look behind are actually assertions. They don't consume anything. They don't match anything. They only qualify an existing match. Here, what I'm going to do is I'm going to say, go through this string and match any digit character. And you can see it pulled out all the digit characters. That's great, except I didn't want to match the digit character if the digit character happened to be followed by that comment saying skip. So what I can do is I can say, match any digit character, question mark, exclamation point. This is a negative look ahead. Match any digit character as long as the thing next to it I am asserting is not a skip. And when you see that, you can see, oh, hold on a second. It did exactly what I told it to do. It matched anything where the next character, any sequence of digits where the next character wasn't a skip, so it matched just these two, the 4 and the 5, because it was too smart for my own good. And so if I want to fix this, maybe what I'll do is I'll say negative look ahead on just the string, have a single space, and then negative look ahead on this, and I believe that captures exactly what I want. And the way this works is, what I'm going to do is I'm going to say match anything that is a digit character and put a space at the end of the line, and because these lines are new line terminated, it'll take the new lines and then put the skip here. That's a little bit hokey, but at least it actually kind of matches. And so I got something going for me here, and I was able to use this negative look ahead. And you can see if I remove this, it matches the 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this negative look ahead and the negative look behind, the positive look ahead and the positive look behind are a little bit trickier to use than they might see, but they're incredibly powerful tools. And where you're going to use these is probably not in Python as much, unless you want to have really big, complex regular expressions. Maybe the case that you might want to have a regular expression that you can use both in Python and in your SQL query and in your grep query and in your editor. So a lot of this comes up when you want to have the regular expression contain all of the computation, because you're not guaranteed to be able to write ad hoc code around it. And this is where generally I find I use positive and negative look ahead and look behind. Cases where I need the regular expression to have all the complexity, because I need that regular expression to be able to move around between different parts of my system. I can't just do this easily by saying, oh, match everything, and then have Python decide whether to accept that match. Let's take a look at what positive look ahead is. Positive look ahead is the idea that you are explicitly looking for something next. And so here, I could match a 1, 2, 3 or a 7, 8, 9, but not the value equals question mark with a very simple regular expression. If I wanted to allow for any possible value, like maybe I want to allow for some string values, I could say match anything. And here you can see this matches anything. It matches the hello, the 1, 2, 3, but it doesn't match the DEF all by itself. So I could, do a star match. Okay, so there you go. And it doesn't match the XYZ all by itself. So it only matches anything where it's something equals something, and I get to see what the part that is being matched here. And what I could do if I really wanted to make sure that there's a match or not is I could say, oh, match one or more of anything and make that optional. And you can see that gives me a none instead of an empty string. Okay, that's kind of useful. Well, where our positive look ahead works is what we're going to say is only match something if the next thing happens to look like something. So I can actually rephrase this very slightly. I can say match any character as long as, actually this would probably be a negative look ahead, as long as the next thing isn't a new line would be one way to match this. And so probably I don't need the positive look ahead here. In this case, for the positive look ahead, I might want to match anything except the XYZ. And what I could do is I could say, compile this and match any word character, and then only match it if the next thing happens to be that equal sign, and then match anything more. So this should capture for me just the portions that I want, just the, let's double check that works. And this should capture just the word characters and then something following an equal sign and then that. And so here we go with a positive look ahead, and it doesn't cap, and then there we go, that's good. And let's make sure this works. So this should be capturing any one of these. And this is where we start trying to debug our regular expressions. So let's start with something that we know works. That works there. I'm going to say capture this if this is a positive look ahead. And so the positive look ahead looks like this. There we go. There we go. So it matches anything which has a positive look ahead and then anything after it. And if I put a star here, then you can see it should match. Oh, and I'm assuming there's a space here, so I'll take that space off. There, you can see it matches the letter and then the equal sign and then anything at the end. So you can see the positive look ahead is basically about matching something, but the positive look ahead, these look aheads are assertions. They don't capture anything. This group here captured the equal sign. This doesn't say match the equal sign. This says only match if there happens to be an equal sign at this particular position. Now let's take a look at the positive look ahead. And where you can start to see this might be useful is, what if I want to match a bunch of elements and I want to use findAtor on each one of these lines. So I want to get the XYZ, the ABCD, all of these elements, and there may or may not be a trailing comma here. And maybe what I want to match is whether you're at the beginning of the line, the end of the line, or in the middle of the line. Here, if I do this, this is going to match everything except the last elements if they don't have a trailing character. So I'll make that comma optional. And you can see it matched the A, B, C, D. Here, I'll clean this up a little bit for you because you don't really care about what these look like. You only care about the matches. It matches the A, B, C, D, the X, Y, Z, and the G, H, I. What if I only want to match some of these characters? What if I only want to match anything that's not at the end of the line? Well, what I could do is I could say, give me a comma and match anything where there's something following it. Match only if it's that word with a comma and something following. And so notice, it doesn't match the last character. It didn't match the D. and it's irrespective of whether there's a trailing comma or not. It matches anything as long as there is something in front of it. This is where that positive look ahead might work. And in fact, we can use this with negative look behind as well. Basically, the look ahead, look behind is really just about saying look around and determine whether something's before or after in this match, and then perform the match. And we could do the same thing, because you could think one thing we want to do with this data is we might want to say match each one of these characters, and as part of the matching of these characters, figure out, are you at the beginning of the line, the end of the line, or the middle of the line? Are you the very first element, the middle elements, or the last elements? And here you can see I'm matching everything. If I want to be a little bit more careful about what I match, I could use a negative. This is a negative look ahead. So this says match anything which is not, or assert that at this point in time, there's no characters. So that didn't quite work. Maybe I want a negative look behind. Here, this says match any word character with a comma as long as it is not preceded by another character, but there's a problem with the look behind. If you think about how the backtracking might work, the negative look behind is going to create a lot of backtracking. One of the rules of this negative look behind is the pattern has to be of fixed size. You can't use these quantifiers. The pattern has to have a certain number of characters. And this is in part in order to allow you to create your finite automata effectively. So I'm going to write this like this. I'm going to say match any word character with a comma as long as there's nothing in front of it. And I match the very first character of this. I match anything that doesn't have something in front of it. That's the very first character line. So if I can match the last character line and the first character line, I could write a very complex regular expression to match the first, middle, and last. And that's what this is right here. Here, I have a complex regular expression. I'm going to have a non-capture group with three possibilities. Either the first item, the last item, or the middle item. For the first item, I am using a negative look behind. I look behind and I say, as long as there's nothing in front of me, then you're the first item. For the last item, I'm going to use a negative look ahead. As long as there's nothing in front of me, match. Okay, that would mean you're last. And for the middle item, I'm going to use a positive look ahead and a positive look behind. As long as there's something in front of me and there's something behind me, then you're in the middle. And take a look at what this did. This is actually fairly sophisticated in terms of what it does. Here, what I managed to do is I managed to match every one of these letters, A, B, C, and D, X, Y, and Z, and G, H, and I, and I managed to classify whether they're the first, whether they were the middle items, or whether they were the last items, using the positive and negative look ahead, positive and negative look behind. And I used all of these in order to do this, with a non-capture group just to specify that it's one of these possibilities. And there you go. Your look ahead and look behind tend to be one of the places where people kind of give up on regular expressions and they say, look, I'm just going to do this in code. And I think that is completely fair because these get very complicated very quickly. But there are circumstances when, for example, you're writing an SQL query and you're trying to do a regex within your SQL engine and you don't have the ability to write arbitrary code. Or you're trying to do this in a grep-like formulation. You don't have the ability to write arbitrary code. You need the regular expression to contain all of the logic. Well, you really don't have another choice, and this is where you're going to use your regular expression. Whether this regular expression is more or less efficient than doing it ad hoc, I think is largely immaterial because what really comes down to it is if you could do this ad hoc and it was more understandable, you're probably better off in the long run than writing some complex regular expression that nobody can read. But I do want to share this with you to show you the power of what you can do with these regular expressions. They can match contextually based off of what's around them. Additionally, you can reference parts of the match. So if I was going to match strings that began and ended with like quote characters, here I have a very generic matching, and this generic matching, matches any value, any number of characters. What if I want to match up the quote characters? Well, one thing that I could do is I could say, okay, match the variable, then match an equal sign, or the variable name rather, and then match any single quote or double quote, then the value, then any single quote or double quote, and it would match all three of these. But it wouldn't match, but it would still match if these were not balanced. It wouldn't match this, it wouldn't fail to match if this is like starting with an open quote but ending in a closed quote, and I want that to be the case. I want these to be matched up. Well, what I can do is I can make these a named capture group, And then I can specify that this thing has to be that same name capture group. And now it will not match the unbalanced quotes. I can match something and then say only continue the match if that same thing comes up later. Extremely powerful. And if I wanted to extend this example so that I could even quote out some of these characters, I could have some sort of like backslash escaping of these. I could even do this so that here I could match. I'm going to try and match any single double quote, any triple double quote, or any single quote, and I'm going to allow myself to escape these single quotes. Well, if I want to take this original regular expression, it matches everything, but you can see it does some things that are kind of dodgy, like this some other ends a little bit early, and it's not checking that it's either single quotes or triple quotes. It's not checking if it's double quotes or single quotes or triple double quotes or single or double quotes. And so I'm going to have to make this a little bit more complicated. What I'll do is I'll use alternation, and I'll say either match 3 of these or 1 of those. And so now if somebody tries to use double quotes, that shouldn't match. And here, the value, and we need to make sure that this thing, we have to put an assertion here, as long as this is then not followed by a double quote. So we'll do a negative look ahead assertion. So here, yeah, this gets a little messy. So we're going to do a negative look ahead with a single quote. And here I'm going to actually make this a little bit simpler. We'll do it like this. We'll do our alternation like this. There we go. We're going to have to start making some of these non-capture groups. So we're going to match 3 or 1 double quote, as long as it's not followed by a double quote. And then we're going to match this same thing on the other side. Or we're going to match 3 or 1 single quotes, as long as it's not followed by a single quote. So we don't get the 2 double quotes or 2 single quotes get matched. And so here you can see it didn't match yet another value, but it did match some value and some other value. So here that seems to be working. And then the last piece is, for this, I don't want it to match. I don't want it to close if there's a backslash escape. So what I'm going to do is I'm going to say, okay, take the previous thing, but put a non-capture group here. And as long as this thing isn't preceded by a backslash. So I'm going to do a negative look behind assertion, like that. And you can see, as long as this isn't a single backslash, so this is where it starts to get a little bit, okay, hold on, this has to be, yeah, that's good, oh, this has to be like that. And there we go. You can see it matched the escaped single quotes. Would I do this if I didn't have to? No. I mean, this is getting really, really, really difficult. But you get an idea for what you're able to do. Now, another very sophisticated thing that you can do with these regular expressions is you can refer to previous matches and choose to keep those previous or choose to use those previous matches to drive other matches. There's actually conditionals in Python's regular expressions. In other words, if I wanted to match either a numeric value or a parenthesized numeric value, but not a partially parenthesized numeric value, what I could do is I could say match at the beginning a actual parentheses, right? And if I happen to match that actual parentheses, then match a closed parenthesis, or if not, don't match anything. And then here we go, and here, this should be called P. And let's see if that worked. So here you match an actual open parentheses, and this should be optional. And here that got the 1, 2, 3. Otherwise, match. If this match, this is what's called the yes match and the no match. Now it should be like this. And otherwise, we'll end the string. I think that gives us what I want. Or we can do something like this. And this is where this like ID-based matching is. Okay, so here we're going to match that. And if that happened to match, then we want to have a close parentheses here, so this is right. Otherwise, we want to have something like that. And so here, let's do this without this portion. Let's just put one of these at the end, show you a little bit of how we do that, and then let's not name this for a moment. Okay, and why doesn't it match the DEF? Because here this is a actual parenthesis with a name, so let's simplify this a little bit. Let's say an actual parentheses here and an actual parentheses here. It's always important to break this down to small pieces if things don't quite work the way you want them to work. And yeah, that's, oh, and it's just around the value portion, that's why. So it's just around the value portion here, and so now let's build this back up and say we'll name this thing, and we'll say that's optional to match. And if that match happened to have happened, oh boy, then make use of that information. And so you can see it matched the 1, 2, 3 and the 7, 8, 9, but not the unbalanced parenthesizing. You can even do that with these back references.